Welcome to the last section in Chapter 8. This is Section 8.6. And we are going to be comparing all the functions that you guys have learned up until this point for the last 32 weeks of school. Okay, you should have copied this into your notes. You all know y equals mx plus b. This one you're familiar with. We've done a little bit. And then quadratics. You should know what they look like. You should know what makes them go up, down, upside down, left, right, wider, skinnier, right? All those. Okay. So let's see if we can tell. How do we tell whether or not each of these are linear, exponential, or quadratic? So it says to plot the points. That's the easiest way, and it's also the longest way. So you're going to have to put on your paper a very quick sketch. And you have to decide of which of those three functions does it look like. So 4, 4, like here. 0, 0 is like here. 2, 0 is like here.
Oh, I think that's quadratic.
Okay, so let me think. Yeah, you start guessing, right? 1, negative a half, negative 2, and 4. What is it? Quadratic. Okay, do you guys get it?
Yeah.
So let's do this one really quick. 0, 1, 2, 4, 4, 7, negative 2, negative 2, negative 4, negative 5. I didn't do it perfectly, but I'm assuming that would be linear, straight line. Okay, so then we're going to plot these. 0, 2, 0, 2, 2, 8, 1, 4, negative 1, 1, negative 2, a half. Oh, you see a curving, so this one is an exponential. Good. Okay, so moving ahead, these are more problems. Okay, so here are the differences between them. In a linear function, the rate of change is constant. Okay, in an exponential function, the consecutive y values have a common ratio. We're going to explain that in a second. In a quadratic, the second differences are constant, and I'll explain that in a second. Okay, so let's look at this. Tell whether or not it's linear, exponential, or quadratic. Okay, so let's look at the rate of change, first of all, just to see if it's linear. The rate of change is delta y over delta x. Okay, so what's my change here? Negative 3. What's it here? Negative 3. Negative 3. What's it here?
1. Plus 1.
Yeah, plus 1. Okay, so y over x, what do you notice? Is it constant?
Yes.
So that means this one is linear. Yeah, it's slope. Same thing. Okay, so now let's look at B. So let's look at the change here. This is plus 1. This one is plus 2. This one is plus 4. This one is. And then what is this one? Plus 1. Plus 1. Plus 1. Okay. So I know we're also saying plus is here. It's also multiplication, right? So this is really times 2, times 2, times 2, times 2. Okay, so this one is exponential. Okay, we're going to scroll down here. There's a third one. Okay, change here is plus 1. Change here is. Now, I'm going to write this here on the side just because it's going to be more space. So do you notice the first change is minus 1? The next change is plus 1. The next change is plus 3. And the next change is plus 5. Okay, I'm not noticing any addition constant, and I'm not noticing any multiplication constant. Here's the next thing you're going to check. This is the first set. The second differences. So from here to here, from here to here, from here to here. What's the differences here?
0.
From -1 to +2. From +1 to +3. From +3 to, okay, so the second level changes are constant. So if the second level changes are constant, it's a quadratic. All right, so in looking at number 21, did you figure out if it was a linear, exponential, or quadratic? Quadratic, okay. So the second part of this lesson, which I haven't shown you yet, is that how do we write the function for this? That's how. So let's look at these points. Just by looking at these points, you can't automatically tell if one of them is the vertex. But there's something else that you can automatically tell. You can automatically tell the y-intercept, but there isn't a y-intercept form. So what else can you see right away? You can see the x-intercepts. So where are the x-intercepts? Good. -1 and 0, and 2 and 0. Those are the x-intercepts. So since I know the x-intercepts, let's use intercept form. So it's going to be x plus 1 times x minus 2. Okay, let me write down the original equation because I think you guys are x minus p times x minus q. And there's an a here. Okay, now I want to find out what a is. I don't have a, but I do have an x and y. Look how many x and y's I have. I can use any of these points. So pick any of these points. It doesn't matter which one you use. Which one would you like to use? Yeah, I'm going to use this one. That makes sense to me. Okay, so now we have it. -4 equals a times 0 plus 1 times 0 minus 2. -4 equals a times, this is 1 and -2, times -2. Divide both sides, so a is going to equal 2. So here's my function, or y equals 2 parentheses x plus 1 times x minus 2. Okay, I think you need to write it in standard form. Yes, you do. So let's write this in standard form. Y equals 2 times, what is this? X squared minus x minus 2. Y equals 2x squared minus 2x minus 4. And that is my function. What did you figure out? Exponential. Good job. What was it? What was the constant? Did you guys figure out? From here to here.
X equals by 1 and y.
Yeah, it's the y's. What's happening to each of these y's?
Multiplied by 1.
Yeah, it's being multiplied by 1/2. Do you guys see that? Okay, so here's how you write the function. It's super easy. Once you figure out that it's being multiplied by 1/2, it's really y equals ab to the x, right? So the answer is going to be y equals 1/2 to the x. Number 23, and I'm not going to write down the table, but what did you figure out with 23? What kind is it?
Linear.
It's linear. Okay, so we all know what the linear equation is. Y equals mx plus b. Okay, so what did you find out with the slope? What is the slope for that one? What was the change in the y over the change in the x? It was not -1. It was -3. Good. So 3x. And then which one was the y-intercept? Minus 2. So y equals -3x minus 2. Yeah, the linear ones are the easiest one because you did them all last semester. So remember your slope. Your slope is your change in your y over your change in your x. Let's just continue on to number 24. And I take back what I said before. So what did you figure out? I'm just going to write the table this way. 0, 5, 1, 10, 2, 20, and 3, 40. Okay, so I'm going to take back what I said from the last one about A and B. Okay, so this was exponential growth. You guys saw that. All right, what was my constant?
2 times 2.
The constant was 2. So that 2 is your B. So y equals a b to the x. And in the last problem, I didn't give you your a, which I should have. I take that back. I'm sorry. Your a is going to be whatever is paired with your 0. So what's paired with my 0? So it's going to be 5 times 2 to the x.
We don't know the power yet, right? Like the x.
The reason why, let me explain why I know that it's the 5. If I plug in 0 for here, 2 to the 0 power is what?
1.
Is it 1 or 0?
1.
It's 1. So